Hello, in this video I'm going to show you how to build a SQL agent using LangChain. SQL agents are able to answer questions based on information stored in a database. SQL agents have the ability to make a plan before they answer the question, so they are using the reasoning abilities of LLMs to come up with the best way to answer the question. Also, they are able to submit multiple queries to answer the questions. They are not limited to a single query. They also can recover from errors. If they come up with a SQL statement that is not correct, they keep trying until find the right approach. Finally, in a similar fashion as retrieval augmented generation, SQL agents, once they retrieve the data from the database, they can elaborate a final answer using that information rather than just presenting it. Let's begin. This is an adaptation of the LangChain tutorials. So if you want more information about this, you want to dig a little bit deeper, go to the tutorials and you'll find more information. Before we begin, let me talk about an additional file I created. This is a new class called SQL Agent. This simplifies the process of creating the agent using the LangChain toolkit. To be initialized, it takes 4 parameters. One is the model provider. That could be OpenAI, WatsonX.ai, Grok. Then the model name, that's the name of the LLM. Then the dialect, which is the type of database you're going to connect to. Then the database underscore URI. This is the location of the database. And then how many results should be retrieved for every query. One more thing, before we start, this example is using the Chinook database. This is a sample database that is widely used for educational purposes. For those who haven't seen this before, is very simple. It has information about sales of albums and tracks. So one of the main tables is the invoice table. It has the total of the sales, and it also has more details in the invoice line. It has the tracks associated with that sale, the unit price, and the quantity of those particular items. These lines are associated with tracks. Tracks are the name of the songs, including in the sale, and they are associated to an album, and albums are associated to artists. There's some other information like playlists and media types. We won't use those. Also, invoices are associated to customers, the people who bought the music. Now let's begin. I have created a Jupyter notebook here on the left. This Jupyter notebook is going to invoke the class I mentioned before, and it's going to ask some questions to see how the SQL agent behaves. If you want to run this, you can download these files. The link is in the description of the video. You will have to create an .env file to make this work, and in the .env file, you have to provide the environment variables that your LLM might need. So the first cell here is only setting up my Jupyter notebook so I can use files from a different folder. Now I'm going to import my libraries. These are the libraries I created, the SQL Agent class. Now we're going to initialize the agent. For this example, I'm using OpenAI's GPT-4o Mini. It's a small LLM model, and this LLM will be doing the thinking and the drafting of the final answer for us. I'm also using, as I mentioned before, the Chinook database. It's a SQLite database. So now I have my agent. Is now stored in the variable my agent. And we're going to start submitting some questions to see if the agent is able to correctly answer the questions based on the data of the database. So let's start with something simple. This question, what country has the biggest sales, can be answered from a single table, right? The invoice table has the total sales and also has the billing country. So this question could be answered with a query like this. Select billing country. We're going to sum the total and we're going to group by billing country. Then we'll sort by the total so we have the highest values at the top. And here's our result. USA is the country with the biggest sales with $523. So now let's run this and see what is the answer of the agent. And the answer is here. The country with the biggest sales is the USA, with a total sales amounting to 523. So that's the correct answer, and is giving us even a little bit more information if we want to see the top 5. So that's the correct answer. It did a good job. Now, in this example, I just printed the answer coming from the agent. But if you want to understand what is happening behind the curtains, instead of just getting the answer, we're going to stream the answer, which means we're going to be able to see every step of the process of generating the answer. So let's take a look. So we ask the same question, what country has the biggest sale? And this time we get much more information. So I'm going to walk you through this output so you understand what's happening. So the first thing that the agent is doing is retrieving the tables of the database. So it's listing all the tables to understand which tables might be relevant to answer this question. Next is focusing in a couple of tables. In this case, is looking into the invoice and the customer table as potential tables that might have information to produce the answer. Then is looking into the structure of one particular table, the customer table. And then is coming up with a first candidate query to see if this might answer the question. And is doing a select on the billing country sum total from invoice, which is exactly what we ran. So it looks like it's on the right track. Before the query is submitted to the database, it invokes a particular tool. This tool is called SQL DB Query Checker. What this tool is doing is validating that the syntax is okay for this particular database. Once the syntax has been validated, then the agent is actually submitting the query against the database and is retrieving the information. The last step of the agent is, with this information, answer the original question in a readable format, right? And this is the readable version of the answer. Okay, so far so good. The agent is doing a good job at answering questions correctly. Now we're going to make the questions a little bit more complex. For this second example, the query needs to join 3 tables to answer the question. So the question is, what album has sold the most tracks? And so to answer that question, we're going to use this query, and let me explain it first. So sales information is available in the invoice line, but this doesn't have the album information. So to obtain the album, we have to join the track table to identify the album. But this will only give us the album ID, and if we want to have the album name, which is what anyone would expect in the answer, we have to again join this table with the album table to get the title of the album. Right, so at the very least, we expect to have a select that includes the album, the track, and the invoice line tables. And one query that might answer that question is the following. So we're going to select on the title. We sum by quantity. So in this case, we're only counting how many units were sold for that particular track. Then we do the join for the other 2 tables. We group by title. We order by the sum in descending order. And this tells us that this particular album, Minya Story, is the one with the most sales. And there's some other albums there. So let's ask our agent the same question and see what is the answer. So again, we're going to stream the answer. It's still thinking. This time it's taking a little bit longer. It was a little bit more complex question, so that's expected. So now let's inspect the output. Again, is using the same approach. First is listing all the tables of the database to understand what type of information is stored in the database. Then is focusing on a few tables, the album table, the track table, and the invoice line table, which are the ones we use in our query. Then is inspecting the structure of one of the tables. And then is coming up with that first candidate query to see if this works. And is doing a select title, some quantity, is the same query we came up with. So then it's checking that the query has the right syntax, and when it's confirmed that is the right syntax, it executes the query against the database, obtains the data, and then elaborates an answer based on that data. and it's telling us that the album that has all the most tracks is Menu Story with 27, which is the same answer we had here. Again, this is the correct answer. And now I would like to pause this exercise for a moment to show you a key part of this process, which is the system prompt. The system prompt is the underlying prompt that is included in every interaction with the database to control the way agents interact with databases. And here is the prompt. This is the default prompt template provided by LangChain to create SQL agents. I'm not going to read the full prompt, but you can pause the video if you want to read it. As you can imagine, this is a key component of the agent. And if you start observing some problems in the way the agent is elaborating queries, you may want to go back to this prompt and fine-tune it to correct those mistakes. Also, if there is something particular about your database, either your naming conventions or the concepts stored in particular tables, this again is a good place to store that information, that knowledge, so that the agent can use these instructions every time it builds queries against your database. More on that later. Now let's take a look at a few more examples to show you some other interesting aspects of agents. To answer our next question, you have to submit multiple queries. So we're going to challenge our agent to answer something more complex and see how it behaves. So the question is, what is the average duration of the top 5 best-selling tracks? And so to answer this question, you first have to identify what are the top 5 best-selling tracks. You can find that information by doing an aggregation of tracks and aggregating the quantities. And then once you have identified what are the top tracks, you can use the milliseconds column in the track table to identify what is the average, right? So there's 2 steps to this logic. A query that might answer this question can have this shape, but this is not the only version, of course. So in my approach to answer this, I'm running a query that first identify the top 5 tracks by quantities, and then I'm doing an average for those particular 5 queries. And I can have the average. Okay, let's see what the agent is doing in this case. Okay, as we know, first is using this particular tool that lists all the tables, then is inspecting the schema of some of these tables, and then is coming up with a query to answer this. This is the first approach. And in this one is listing the tracks and the milliseconds of each track. And then it's trying to order by the sum of the quantities. But this is not going to give the average, or this is not enough. Let's see what happens next. Yeah, so that query is bringing the duration of some of the tracks. Then it comes up with another query. Select the average millisecond from the previous query, okay, which is similar to what we did, right? So it's identifying what are the top 5 selling tracks, and then it's doing the average, which is similar to what we did here, and it's coming up with this answer. And so it's telling us the average duration of the top 5 best-selling tracks is 268,338 milliseconds, which is the same answer that we had obtained manually. So again, very good job. It was able to handle a question that required basically 2 queries to be answered. Now this is the final question we're going to ask. This question is more difficult because it requires 3 different queries to be answered. So the question is, what % of customers bought tracks from the 2 albums with the highest sales? So to answer this question, first we need to identify what are the 2 albums with the highest sale. So you have to join albums with tracks and invoice lines to identify which album had the best sales, and then you will have to identify how many customers bought tracks of those albums, right? So you will have to join invoice line with the invoice to identify how many customers. And then you will have to know how many customers bought tracks to calculate the % of people who bought tracks from those albums. So a query that answers this question will look something like this. So again, the first step in this example is I'm selecting what are the albums that sold the most. To calculate that, I'm joining the invoice line with the track, and I'm grouping by album ID, and I'm ordering by the sum of the unit price and the quantity. Because when I refer to highest sales, we have to take into account not only the quantity of sales, we're also including the amount of dollars associated with that sales, because tracks have different prices. Once we have identified what are the top two selling albums, then we can do a select distinct of the customers who bought albums in that dataset. If I execute this, there's 13 customers that bought tracks from those albums. And the last piece here is to identify how many customers have bought albums in total. It's 59. And so if we divide 13 by 59, we will have the percent value of this. So let's run the full query here, and we have the result is 22%. Okay, so we're going to run the same query here and see if the agent is able to answer these complex questions that requires multiple steps. Okay, let's see what it's doing. First, retrieving the tables. It identifies a few tables that can be relevant. Album, invoice, invoice line, and track. Those are correct. And then in here is doing a count distinct of customers from invoice. So this is retrieving the total amount of customers, 59. That is needed for the final calculation. Then is doing a select track album sum invoice quantity as total sales from invoice line. Okay, so the agent is getting a little bit confused at this point, and I think it's understandable. Is identifying what are the tracks with the best sales based on the quantities of the invoice line. This is an approach of identifying the albums with the highest sales just by quantities. But I think a better approach would be to consider the dollar amount, right? Because some tracks, as I mentioned before, have different prices. So I was expecting this to multiply the quantity by the unit price to calculate the total sales. Let's continue and see what happens next. Once it has gathered all the information, it comes back with the answer and is saying the two albums with the highest sales have the following total sales: album ID 23, album 141, 27, and 26. So again, it's considered sales as quantity of sales, not the dollar amount. And based on that, it's calculating the percentage. So let's just take a look at the final answer. It's saying that approximately 42%, which is different what we had. So what we need now is to tell the agent, we need to teach the agent that we have something specific in mind when we refer to sales. How do we do that? For that, we're going to modify the system prompt. Remember, we had seen what was the set of instructions we're submitting to the agent every time we interact with it. So we're going to just use the same template and we're going to add an additional instruction. So in this cell, I'm adding this final step. Sales are defined by the product of quantity and unit price, not just quantity. So hopefully, by telling this in the system message, the agent will take this into account every time we ask a question about sales. Okay, so I'm going to run these cells. This is going to update the system message of my agent. And now we're going to run one more time the same question, and for which we didn't have the answer that we wanted because it was just also only considering quantities. So let's run it again and see what happens. What we want to see is the agent multiplying unit price by quantity. And it's looking good. Yes, so it is again identifying the top selling albums by calculating the sales, multiplying quantity and unit price. It's identifying the same two albums and it's coming up with the same result, which is the correct result. Now let's do a quick recap. In this video, we have explained what are SQL agents and how they behave. We created a simple agent that can connect to a database and can answer questions using SQL queries. We demonstrated that SQL agents are not only capable of handling single queries or simple questions, but also complex ones that require multiple queries and multiple steps. We also demonstrated how agents are capable of identifying their mistakes and come up with new approaches to answer their questions. And finally, we show how you can use the system prompts of your agent to refine their ability to understand the database and come up with better answers. I hope this video has helped you understand what are SQL agents and how you can create an agent that can help your teams and people working with databases get answers in a simpler way. Thank you.